1 second. I think we're making a small change because in addition to this keynote being recorded, it's also being live streamed for an audience that is not in the room with us right now.
I can't get to Zoom. Oh, glad we did it for you. It's frozen. I can't get to Zoom. Takes an army.
Good.
Oh, wait. It's all good. Now,
Okay. I'm Corey Colleen. I'm the executive director of the Kleinman Center for Energy Policy. It's wonderful to see so many familiar faces and some new faces in the room today. I feel like I have to acknowledge, because I want to be the one that acknowledges it instead of any of you, that there's been a lot of photos of sheep already this morning and a lot of references to sheep. I did not plan that when I picked my outfit this morning, but I am intimately aware of what the scene I've created up here for you all. I have the pleasure of introducing our keynote speaker for this morning, Jane Zelikova. She is the executive director of the Soil Carbon Solutions Center. That's really a mouthful at Colorado State University. She's also a science advisor at Carbon Direct, and that's how we got connected up with her. She's done some work with the Kleinman Center's Clean Energy Conversions Lab, and that's how she first came to our attention. She is a prolific writer. She's published with Nature, with the National Academy of Sciences, with Scientific American. But then in addition to her scholarship, she's done a bunch of other really interesting things. She's the co-founder of 500 Women Scientists, which is a global grassroots nonprofit organization with the mission to serve society by making science open, inclusive, and accessible, and fighting racism, patriarchy, and oppressive social and societal norms. I don't know, I mean, what bigger calling could there possibly be? It's amazing. She's also the founder of Hey Girl Productions, co-producing and starring in the film End of Snow, which has been featured in National Geographic and Outside Magazine. And I think this emphasis on the communication, that kind of this intersection of science and policy, which is a particular interest to us at the Kleinman Center, is going to be one of a few topics that she's going to be covering in her talk today. And I also want to say, I know that Jane really had to move mountains in order to be here today. We've been working on bringing her to Penn for a while, and I know it was not an easy thing. So I'm especially grateful to you for making it work in your incredibly busy schedule. So welcome, Jane.
I didn't move mountains, but I did have to fly over some mountains to get here. I'm so excited. Thank you so much for the intro. So excited to be here today. From Colorado State University, the Soil Carbon Solutions Center is similarly a relatively new endeavor at Colorado State. It is also meant to be an interdisciplinary center that brings together 5 colleges at Colorado State University, including the College of Agriculture, Agricultural Sciences, Engineering, Humanities. So the idea really is to build something very similar to what you are building here. We're also about 2 years in, similar to you. I'm in the job for 1.5 years, and we're trying to bring interdisciplinary tools to solve global challenges. So lots of similarities. I'm really excited to learn from you all and how you're setting up these interdisciplinary collaborations. It's not an easy thing to do, but it's really critical as we're facing increasingly interdisciplinary problems. So today I'm going to talk to you about climate solutions, justice, and the rise of what has been noted as a $1 trillion industry. I can't even fathom that much money, but that's kind of what people are saying about carbon dioxide removal. And so just, this isn't a room where I need to really go into the detail of the climate imperative, but I'll just say that we are in a climate crisis. There's no question about it. And that carbon removal or the mitigation of carbon emissions in the atmosphere has, been now deemed essential, not just advisable, but essential. One of the latest IPCC reports, and I know they're coming out quite a lot. So not the one that came out this week, but the previous one, which was last year, used words like carbon removal is essential to really kind of signify that this is no longer a question. We're not on a trajectory where we can avoid having to remove carbon from the atmosphere. And the level to which we have to remove carbon, it really is probably about 10 or more gigatons of carbon per year by the end of the century. That's kind of what we need to get to in order to both kind of address the emissions we can't abate and remove legacy emissions from the atmosphere. And carbon removal includes a lot of different pathways, from things that are called nature-based or natural, which is a word I don't really like, but solutions rooted in sort of the biosphere, to solutions that are technological or engineered, and kind of through this. Is there a thing? Yeah, there's a thing. Huh? Maybe not a thing. No, not a thing. Okay. Well, so we have soil carbon or agricultural systems are included in the sort of toolbox of carbon removal solutions. And specifically, what is being called out is sort of the ability to sequester carbon in soils through managing forests and managing agricultural lands. And so agricultural systems both contribute to and have a lot of emissions associated with producing food, and are particularly sensitive to the impacts of climate change. And it's really important that we note that when we talk about carbon removal in agricultural systems, we're not just talking about climate mitigation, but we're also kind of need to address the fact that agricultural systems are already very vulnerable to the changes in climate, and that's only going to increase over time. And they also obviously offer opportunities for climate mitigation. And so today I'm going to talk to you quite a bit about what it means for soil to deliver on its sort of climate mitigation promise, and then all the different ways that can go wrong. So this is soil's moment. Soil is having this wonderful moment in the public. All of a sudden, it has captured our collective imagination. People are really excited about the potential to connect with our soils. People talk about how soils are beautiful. I am one of those people that talks about that constantly in my Instagram account. And interest in agricultural soil carbon is particularly on the rise, from sort of the research that's focused on it to the media attention that it's garnered. I don't know how many people have asked me if I've watched the various documentaries on Netflix about agriculture and soils. They asked me what I think about it, which I have a hard time controlling my face, so it always kind of betrays me. And usually I'm very skeptical, but I'm excited that people are excited about soil. That's the part that is undoubtedly a good thing. Interest is also growing in terms of research. So this is a paper that came out last year that looked at the publication of other papers. If there was ever a more academic meta moment, I can't imagine one, where academics are studying the number of papers other academics are writing about a topic. And so in this case, you can see that the number of publications that are focused on soil carbon sequestration is on the rise, and has been kind of since about 2005, but it's really high right now, and it doesn't look like it's going to be abating anytime soon. And then if you look at like soils and climate mitigation, that's also even bigger on the rise. And so this idea of soil carbon sequestration and removal is what's getting a lot of the attention. Less attention is being paid to the potential for soils to help with climate adaptation. So we're kind of focusing on mitigation, carbon removal, carbon sequestration, less so on the increasing of resilience and enhancing sort of working lands and their ability to adapt to climate change. So just kind of want to note that this is a moment in time. It is also often touted as a win-win solution. Sometimes we get a third win in there, depending on who's talking. But the idea is that soils can deliver multiple benefits, including climate mitigation. And so this is a paper published by Fargione and folks at the TNC that looked at sort of the ability for nature-based climate solutions to help reach certain goals by 2030. And you can If you've seen this paper before, I've seen it maybe too many times. One thing to note is that lots of opportunities for climate mitigation are available in the ag and grassland sector. We also manage grasslands for agriculture, so it's a really big area, including sort of the ability to deploy things like cover crops, et cetera, to do climate mitigation at potentially low costs. And so this paper looked at the different cost profiles of deploying these different nature-based solutions. And they also looked at the potential to deliver other benefits. And this is really tiny, so you can't see it, but there's little like lines of different colors along with the different solutions next to the bar graph. And, basically air, biodiversity, soil, and water are certainly things that can be enhanced by deploying these solutions. So we love soil. And soils are also happening at this nexus of all of these other challenges. So, and they are delivering lots of different benefits to society, which is another kind of problematic framework for thinking about soils, but I'll just use it for this talk right now. And so they, soils deliver water purification, they help us regulate our climates, they mediate nutrient cycling, they provide really valuable habitat for lots of critters, they regulate floods, and they sort of provide food, fuel, and fiber to humans. They give us construction materials, and they also are really important places of cultural heritage for indigenous peoples across the world. So soils are really important. And so how do soils do their magic? How do they deliver this really important thing called carbon sequestration? Well, I'm going to just go over it in high level, and I know that there'll be other talks following mine that will get into it in a lot more details. But basically, the way that carbon is sequestered in soil is by maximizing inputs from plants. They're the proverbial straws that bring carbon down from the atmosphere, and then minimizing carbon losses. And that could be through decomposition, leaching, or respiration. And microbes are really driving the major transformation of carbon in the soil. They're mediating these major carbon reactions. So that's what happens in soils in a very basic level, but nothing is quite this simple. And before I kind of go forward, I want to say a lot of the work that I'm going to be sharing with you today is work that's done by my CSU colleagues, including folks in the Soil Carbon Solutions Center, who are doing this like really foundational world-class research on understanding exactly how soil carbon works. And so this is work that was published recently by my colleague, Francesca Catrufo at CSU, looking at, in much more detail, what is happening in soils and how soil carbon is transformed in all the different ways that soil carbon can actually exist in the world. And this is a paper that was looking specifically at grasslands across the world, but you can see there are lots of different delivery mechanisms and different ways that plants deliver carbon to soil, and lots of different things that happen between soil microbes, including bacteria and fungi, that differ in their ability to decompose carbon. And different types of structures of carbon have different sort of stickiness and how long they spend time in soil before they return back to the atmosphere. So it's a really complicated system, and one that is we're still learning a lot about. So one thing to note is like we don't know everything yet, and that's a key kind of takeaway. We know a lot about soils, but we don't know everything, and we don't know how to predict it very well because soils are so tricksy. And one of the tricksy things about soils is that they're really difficult to measure. So all the different ways that we measure soil carbon include things we do directly and things that we infer. So directly, we can go out into the field, dig a soil pit, or use a soil core and collect a soil sample. How many of you in the room have ever done that? Quite a lot. And it's a fun part of being a person who studies soils. And there are lots of issues around how we figure out where to sample in the first place, because soil systems are heterogeneous, plant systems are heterogeneous. Those layers of heterogeneity make it really difficult to figure out how to sample adequately to represent the variation that we see in the system. So I put in here to stratify or not to stratify. It is a question that plagues many people who are trying to sample soils. Once you do the sampling, you bring the soils back into the lab. How many of you have ever sieved a soil? It is a thing that happens. So the soil is processed by sieving, grinding various various ways that we do that. And then eventually they're run on instruments to get an estimate of soil carbon content. We can also use flux towers and measure actual sort of fluxes of carbon in and out of soil. And towers are more expensive to build. We need a lot of them because, again, soils are heterogeneous, but we can use flux towers to essentially measure net ecosystem exchange between the soil and the atmosphere and infer something about carbon processing in the soil. We can also use spectral methods, indirect methods of measurement and satellites to infer how much carbon we think is in the soil based on some other measurements that we're making and the relationship between something we can measure remotely and something that we know is happening on the ground. So usually we measure either bare soil and infer something about carbon and ground truth it, or we measure vegetation cover and infer something about carbon from that. But these are inference techniques, not direct measurements. And then we also use models. And I just listed some of the models I just could come up with off the top of my head. There are many, many models that we use that sort of try to describe what is fundamentally happening in the soil and the ecosystem processes that are driving carbon transformation. I'm including things like DECENT, which is a model that CSU developed and is one of the ones that are really popular in the current kind of market system. Others include DNDC, SNAP, ROTHC, MEMS, MIMICS. It just goes on and on. I don't even touch the labs that are the models are developed by national labs, which are also many. So these are the tools that are in our toolbox, and they vary in their ability to predict how much carbon there is in soil, and certainly vary in their ability to predict carbon change. And so we can't value what we can't measure. And the thing about measuring soil carbon is that it's really hard. We need to take a lot of samples. There's no one size fits all approach to how to sample any given location. There was a study that just came out last week that looked at different sampling strategies for the top 10 centimeters of soil. And what they found is that there's no one strategy that fits all the locations. They looked at 3 or 4 different sites on working farms and found that a particular approach worked well in one farm, but not another. So that makes it really hard. If you don't know how to sample soils, then how are we going to know if the numbers we're getting are right? And what does it mean to be right? And so we can't measure soil carbon from space. All we can do is infer. So when you have all these new companies that are claiming they can measure soil carbon with remote sensing, we have to ask questions about how and how much ground truthing is happening and what are the relationships they're actually building their estimates on. And we don't yet have instruments we can take out in the field and measure soils really rapidly. And that's a really big area for potential innovation. And probably where we can make the most progress is integrating all the tools that we have today to get closest to the best estimate of soil carbon. And that means that we have to take measurements across lots of scales. So from the very in the ground, you went out and you sampled and you pulled out a soil sample, to doing a bunch of those samples in a particular area, to using indirect instruments, spectral analyses, and then remote sensing, stacking all of those together and making some predictions and doing that in lots of places. So we build a really good system for estimating and use models to help us make estimates in places where we didn't sample. So this is probably the area where there's kind of the biggest need for innovation. And so as we think about deploying these measurement systems, we also have to think about where there's potential for us to sequester carbon in the first place. And so in agricultural systems, we need to think about where do we grow food, fuel, and fiber. And those areas are kind of noted here in green and brown, brown being areas where we have mostly rangelands or grazing systems, and green are areas where we grow crops. And of course, there are areas where both are happening at the same time. So this is kind of a map of opportunity. These are places where we could potentially harness some tools or some approaches to help increase carbon storage in soils or sequestration. If we zoom in a little bit, we could also think about Not all areas are created equal. Some soils are particularly well suited to store more carbon because they can grow more plants, or they have particular mineral characteristics that make the carbon molecules in the soil more sticky. And so we can think about areas where we have the highest technical potential for carbon sequestration. In the US, you can see the darker areas are those areas with higher potentials. Many of those are in the Midwest, where we grow a lot of our crops and fuel. Mostly fuel, actually. And then what is the potential to sequester carbon in soils? Well, that varies quite a lot. And this is just kind of a summary of the various papers that have come out over time. This doesn't include some of the latest ones that have been coming out lately. And you can see that about 2 to 4 gigatons of year of carbon dioxide can be removed or stored in soils per year. There are some papers that have, included the deployment of biochar in combination with compost, et cetera, and that pushes those limits up quite a bit. But generally, I tend to think we're in a 2 to maybe optimistically 4 gigatons a year range. So it's meaningful. It's about 10% of the US's annual emissions, and it could potentially be enough to offset most of the agricultural sector emissions in the US. So it's not nothing. But it's not going to save us. So when you see soil will save us, be skeptical. We also can think about where we've lost a lot of carbon to begin with. So agricultural systems, and especially cropland systems, have lost a lot of carbon over the last kind of 12,000 years of becoming better and better at farming. And we have an opportunity to put some of that carbon back that we've already lost. And that loss happens through, intensive tillage, degraded grassland management, like grasslands that have been degraded through intensive grazing, and sort of growing crops in a really extractive, intensive way. So we could potentially put some of that carbon back, maybe not all of it, but some of it, because with carbon, we've lost also a lot of soil itself. We can also think about where we can shift management practices. So the way that we manage land matters, and thinking about where we have opportunities to make a change depends on what kind of management we're doing in the first place. So, in Pennsylvania, you can see like the majority of land management is actually for crop production, whereas in Colorado, the majority of our land management is in livestock management and sort of grazing livestock. In fact, more than 50% of our kind of state agricultural income comes from livestock production. So the tools that you would deploy need to be appropriate to the specific practice, the specific land use that you're deploying them onto. And I just want to say that when we talk about technical sequestration potential, this is a graphic that comes out of the latest IPCC. Again, the previous to latest IPCC report, because literally this week another one came out that I haven't read yet. But the technical sequestration potential is sort of based on the biophysical characteristics. What is the soil type? What is the climate? What is the vegetation? What can we expect? But technical potential and realizable potential are very different, because we have economic filters and justice filters that make that greatly reduce the potential for soils to sequester carbon. Like what we can do technically and what we can do economically are very different. And if we, on top of that, put the ability to manage agricultural systems from a justice perspective and lens, which I'll talk about in a minute, it reduces the potential even more. So this is all to kind of lead us towards shifting to regenerative agriculture. The topic of the day is regenerative agriculture, and there's been a really great introduction on what that could mean and sort of the principles that lay the foundation for regenerative agricultural management. But regenerative agriculture is really hard, though the practices are ancient. It's not a technological innovation. There are lots of sort of societal barriers that make regenerative agriculture difficult in today's system. And soil carbon is just one dimension of the many things that happen when you shift towards regenerating your land. And so enabling a shift towards regenerative ag kind of means, this is 5 principles. Sometimes people say 6 principles. Some people change principles out for things that they don't like towards things they like. But generally, we want to minimize disturbance. We want to maximize crop diversity. We want to keep the soil covered. and maintain living roots in the ground, and then where possible, integrate livestock. Every single one of these things is in and of itself sort of flies at the face of current business models in agriculture. And integrating all 5 of them makes it virtually antithetical to the current large agricultural business model. So this is difficult to do technically and is difficult to do economically. And it may in some places be difficult to do socially or culturally. And so there are kind of 3 levers that people talk about to enable this transition towards regenerative ag, and their markets. So either carbon markets, and I'll talk quite a lot about carbon markets. There's sort of the potential for policy change, and policy and markets are really intertwined. And then there's also kind of the need for a holistic vision and sort of the internal and external transformation that is going to be necessary for this whole system to change. And so let's get into it. Soil carbon markets have been, I will just say, exploding, because this graphic seems like an explosion, over the last 5 to 7 years, and especially over the last couple of years. Soil carbon markets specifically have seen a rapid infusion of capital. And so there are 170 different types of carbon credits on the markets, and markets exist. There's kind of 2 big bins of markets. There's voluntary carbon markets where folks are taking voluntary actions and purchasing carbon credits or carbon offsets through voluntary means, not because they're being regulated. And there's compliance markets where there's regulatory action that forces entities that are emitting carbon to abate their carbon, reduce emissions, and purchase carbon credits or carbon offsets for any emissions that they're not able to reduce. So I'm going to mostly focus on voluntary markets, but a lot of the things I'll talk about in voluntary markets apply in the compliance markets as well. So there are lots and lots of different kinds, flavors of carbon credit, including some that are in agriculture, from sustainable agricultural management, livestock manure management, and sort of grassland, rangeland management. But there are lots of other ones, forest markets, cook stoves, energy efficiency, etc. Basically, if there's any relation to an emission reduction or a promise of an emission reduction, it can be monetized in a carbon market. And so this is a snapshot, and this you're not supposed to be able to see. It's just supposed to give you a headache. So if you're having a headache, this is the right outcome. This is a snapshot of a new voluntary market. So this is the voluntary market as it stands today. Pete, you've probably seen this in our Slack. This is ridiculous. And I'll just say there are so many different players and different ways that a carbon credit can come to life and be purchased and retired, that it makes it literally impossible to really know what's going on. I'll just say that basically you have folks on the supply side that are developing carbon projects, and carbon projects are just generating carbon credits. Then you have all of these people in the middle in the blue that are touching those carbon projects in some way and helping things transact. And when you see the majority of the action in the blue, that's by design. The transaction side is like the vampire that takes all of the carbon credit value out of the system. And then you have this buy side folks that are actually buying those credits, either because they're forced to or because they want to. So this is the landscape. And the number of credits and then sort of the money going into this is just exponentially increasing over the last few years. So this is from a publication in, I think it was Bloomberg, where they looked at the amount of carbon dioxide credits being issued and bought, and this is 2020, so it's a couple of years out of date, but you can just see this like rapid incline trajectory. So soil carbon is one of the many types of credits you can buy. It's still a tiny fraction of the overall volume that is being transacted, but it's rapidly increasing, especially when you think about how much money is being put into various carbon market sort of entities and companies, either developing projects or enabling the blue. This blue is getting a lot of money. But one thing that people have started thinking about is whether or not soil carbon or agricultural systems more broadly are well poised to deliver carbon credits. And so this is a paper that just came out like really recently, a couple of months ago, that looked at the kind of the things that we know are necessary for a carbon credit to have value and to actually be delivering meaningful climate mitigation. And those are things like, are we quantifying the change in soil carbon well? Is there additionality? So would this activity have occurred without the infusion of carbon finance? Is there permanence? Are these carbon removals going to actually stick in the ground? Are there other sort of like emission reductions that are associated with the activity? Is there leakage? So like, let's say you do a bunch of stuff here and you do it really well. You're doing regenerative ag on this farm and it's awesome. Does that mean that another farm somewhere else is like doing things more poorly as a result of you doing things really well? Or another good example is like, if you conserve this forest and it's awesome and it's really beautiful, is someone else somewhere else cutting down forest as a result? That's leakage. And then we have this sort of, is there transparency and legitimacy and accountability in the whole thing? Do we know what's happening? Do we have any insight into the transactions? And then are there any synergies or trade-offs? And so the three perspectives that were looked at was based, do we know, like, do we have enough soil science to know that this is happening? Do we know that there's like potential for agricultural management that can actually be leveraged here? And is there governance? And so just to show you, you can't really read everything and I can share my talk later, but basically on the soil science side, it's mostly uncertain. And the only thing we know about is that there are these synergies, that when we sequester carbon in soils, there are all these other great co-benefits and lots of other good things that happen. Whether or not we sequester a lot of carbon or not, there are these other benefits. We know that for sure. That we also know that there are lots of kind of issues with governance, and most of those things say that it's either costly or really difficult to prove. So we don't have the governance and we don't have the quantification in place to be able to be sure that soil carbon credits are real and that they're actually mitigating climate the way that we want. Other criticisms include the protocols that are in place to help generate carbon credits. So different carbon credit registries have different protocols that they've created, which is just a sort of a recipe of instructions for how you generate a carbon credit. And these instructions are pretty convoluted. And if you have to read one of them, you get a bit of a headache. And if you have to read a bunch of them, then you basically have a head explosion. So a couple of years ago, I spent 3 months reading all of them and went into a lot of detail with folks at Carbon Plan about each protocol and kind of broke down its rigor and quantification, whether the protocol was ensuring meeting basic additionality criteria, whether the carbon credits generated were going to be durable, and if there were safeguards in place to ensure the projects weren't going to do more harm than good. We reviewed all of these, we gave them all ratings. You can see the report on the Carbon Plan website. The high level takeaway is that most carbon credit protocols lack rigor, are not additional or don't require additionality, have lots of different ways of getting out of having to be an additional project. And most of them kind of don't have the right safeguards in place to ensure the projects aren't doing more harm. At the same time, these carbon projects could also exacerbate existing inequalities or existing issues with the system. So for example, if you are a farmer who is going to be, and I will just say that almost half of the farmland in the US is leased, not owned. And so if you're a farmer who is working on leased land that you don't own, and you're going to be improving the quality of that land by deploying regenerative ag practices, improving the soil health of your system, making the farm kind of more sustainable in the long term, improving the soil, you as a non-owner operator don't necessarily get the financial benefit of those improvements. Those are kind of garnered by the landowner. And so there aren't systems in place right now to ensure that the landowner and the renter have equitable distribution of benefit, financial benefit and other benefit, ecological benefit. In fact, you can imagine, and as a person who lives in Boulder, Colorado, this has happened to my little piece of land in my house, that as you improve the quality of the land, that the price goes up. And so all of a sudden the landowner can charge the renter more rent because the value of the land has changed. And so that creates a disincentive for folks that are renting land to improve the quality of their soils, sequester carbon, to regenerate. So these kinds of things have to be addressed systematically, and they're not currently being addressed. Other issues that are rampant is that basically any project that's currently signing up for a carbon market program is likely not additional. Lots of early adopters are signing into these programs, which in and of itself is not a bad thing. These folks are doing awesome stuff. They're regenerating their land, they're building soil health, they're sequestering carbon, and they have been for maybe 5, 10, 30 years. The problem is from a climate perspective, those carbon tons are not additional. They would have already been doing that to begin with. And so we have to find ways in the system to incentivize the maintaining of that carbon for folks that have already implemented those practices. Those kinds of things are currently not built into the system. And there's another thing that is happening that I think Beth will maybe talk about, which is that as we focus on carbon, it's another way to bring commodification into the ag sector, which is already very commodified, right? All of these crops are like large global commodities, and carbon is becoming another one. So these are kind of issues to think about. And the other thing that I really want to kind of note, and I think there are some farmers in the room, but most rooms I'm in actually don't have any farmers, and this is often a problem, is we don't know what farmers think about all of this. We know what we think. And so some folks did a study where they asked farmers what they thought about the kind of rapid proliferation of carbon markets. And most farmers are aware of carbon markets. And that's because they're getting, 4 to 5 knocks a week on their door asking them to sign up to a new carbon program. But only 3% are currently participating. That's a pretty low participation rate. And more than 50% are pretty convinced they're not going to participate unless the carbon market systems fundamentally change to meet their needs. And so the things that farmers say are really important for them as they're choosing to participate in carbon markets or not. Annual payments are obviously very important. That's green. But another thing that's really important is sort of the ability to get credit for pre-existing practices, even if they're non-additional. So that to me means we have to decouple climate and other incentive programs. The ability to have minimal paperwork or administrative burden is really important too. So there are these other factors that farmers are thinking about that maybe current carbon markets are not addressing. And so this is from a paper that Holly Jean Buck published recently that looked at these kind of farmer attitudes. The trouble with enthusiasm about high technical potential of soils to remove carbon is that these potentials are going to be constrained by social factors, including whether farmers want to change what they're doing day to day to offer a sink to the world's emissions. So what I take from this quote is that while we can talk about soil carbon potentials, and I am really excited to get to study all the different ways that carbon is transformed in soils, this is happening in a social context. And ultimately, whether or not this happens is really contingent upon what a farmer decides to do with their land. And so the producer considerations really kind of fit into 3 big buckets. The producers, when they're thinking about whether or not to start engaging with regenerative ag, they're thinking about money some of the time, but they're also thinking a lot about co-benefits. So folks that have already implemented these practices outside of carbon markets have really focused on the environmental co-benefits of doing this, and also kind of the social co-benefits. Lots of folks, especially kind of on the grazing side, talk about being a member of a community of people who are doing similar things. So there's kind of a cultural and social cohesion that goes along with doing something that you think is really innovative and cool, and being connected with other people that are doing that too. There are also, farmers talk a lot about educational barriers and the need to de-risk a transition to something new, because transitioning to something new is risky financially and from sort of a stewardship of land resources perspective. And then they also talk about economics, but not necessarily in the I need to make more money, but more that there are these other policy sort of things in the way of them implementing regenerative ag practices. And so what they want to see is sort of policy change that can enable them to get some financial benefit, not necessarily sort of the dollars per acre that a carbon market offers. So transitioning to regenerative agriculture isn't just about climate smart practices that are adopted via education, innovation, and policy support. Rather, it involves subjective, non-material factors associated with culture, values, ethics, identity, and emotion that operate at individual, household, and community scales, interact with regional, national, and global processes. This is all to say, farmers and ranchers are humans that have feelings, that think about the world, that react to the world, that have cultural norms. And so we can't forget about all of that as we focus on commoditizing carbon. And so I kind of just want to mention this project. This is something that just kind of blew up in the last 2 weeks, which is a project in northern Kenya that is focused on grassland carbon. And it's a project that's kind of been like a darling of the carbon markets world. It's gotten all these awards. Folks like Netflix and Meta buy carbon credits from these projects. And this particular project, just a report was published, I think, beginning of last week, that basically said this project is doing really dubious carbon accounting. It's not really accounting for carbon appropriately. The project has a lot of leakage, so a lot of sort of activities within the project boundaries are causing leakage elsewhere. So bad grassland management outside the project boundaries, that animals being grazed within the project actually often graze outside of the project boundaries, and that the pastoralists who are managing livestock in these areas have actually been doing good grassland management and rotation, moving their animals around, following sort of the cues of the land, and they know much better how to manage their grasslands than sort of what a particular carbon market project might suggest that they do, which means that likely all of the credits in this project are also non-additional because they were already managing optimally. And there are also kind of other harms that have been caused to these conservation districts and societies that are difficult to quantify in a carbon credit, but are really important for the longevity of the project and the sort of the do no harm ethos that is supposed to be really important and foundational for carbon markets. And so you can take a look at this report. It's been getting some popular media coverage now, and it's going to be really similar, I think, to what just happened a few months ago, which is that Guardian reporting that looked at a really particular darling forestry project that generated a bunch of carbon offsets that, again, companies like Disney, Meta, et cetera, Google bought credits from, that turned out to be mostly worthless because the credits weren't real. The forest management wasn't really changing the carbon stocks. And that was for the bulk of the project. So that created a lot of issues for Vera, who is the project registry and verifier of these credits. And surprise, surprise, Vera is also the registry for this one. So this kind of thing is happening all the time. It's likely to be really endemic to most carbon projects that are in the voluntary market. So these are just like a few examples, but this is a really endemic issue. Another issue, and this is something that was published a couple of years ago, and again, Carbon Plan did a bunch of really great analysis on it, is that even in the California system, which is supposed to be more rigorous, there is systematic overcrediting in the forest carbon space. Basically, what's happening in California is that the way that the program was set up systematically created these areas where the estimate for how much carbon could be sequestered for a given like ecotone or ecosite was lower than the actual, I think it was lower than the actual amount. And so as folks were creating credits in these forests, they were systematically creating more credits than the reality or the potential for these forests to actually grow and sequester carbon. And so they found about 30% overcrediting in this system, meaning that 30% of the credits that were sold are not real or not actually like representative of carbon stored. And so these are the kinds of things that are happening all the time. And it's just a matter of somebody spending, countless hours, days, months digging into project documents to actually quantify, put a number to how bad this is. And so this is all about like, what if we do this poorly? And I loved this headline so much because people are starting to kind of get smart on this, at least in the media. It's starting to get kind of the attention that I think it needs, which is our carbon offsets the labradoodle of climate solutions. Are we basically just, it's like a fad that we're really excited about? I guess I should ask, how many folks in the room have a labradoodle? I don't want to like dunk on a lovely speech, and I would love to have a labradoodle. So this isn't me. In fact, if anyone has a labradoodle puppy, I will take your puppy. But that's great, and we love labradoodles because they're so cute. But is this a fad that's just going to pass? And if it passes, what are we leaving behind? Are we leaving behind producers that are again disappointed when they get all excited about carbon markets again after the the Chicago Climate Exchange experience? Are we getting them all excited? Are we getting them to start spending money to transition, only to then have nothing to come back to them? And that's kind of the potential harm. Are we creating other harms? If we commodify carbon instead of other things, are we kind of shifting agricultural systems to produce something that isn't actually producing value? So those are kind of the real consequences of doing this poorly. But what if we get this right? And so I get to think, I get to think a lot about why and how we're doing this poorly. And so sometimes I forget that the other side of the coin is that if we do this really well, what does a vision of a regenerative ag system actually look like? And we get to sort of envision that with farmers and ranchers and people that are managing our land. I mean, I think one thing that people talk about when they talk about regenerative systems is that they're focused on lots of things. And the biggest kind of things are diversity, better water quality, sort of better rural livelihoods, people that are managing land that are happier because they're not like growing a giant global commodity crop with lots and lots of chemical inputs, right? They get to like think and adapt to the landscape. And so there's an opportunity to create a vision that is much more exciting than the current agricultural system that we live in today. And for that vision, it's not just about the carbon. And so one thing that people have been talking a lot about, and especially in the social sciences, is this really persistent carbon vision that we have, where we're just focusing on carbon emissions and carbon mitigation, et cetera, and ignoring all the other things that have to be a part of a sustainability transition or regeneration as a broader framework. And when we kind of step out of carbon, which is maybe the easier thing to measure, but is maybe the least sort of indicative of the overall change, we get to improve all of these other aspects of how we grow our food, how we interact with each other, how we regenerate our communities. And so I kind of just want to spend the last couple of minutes proposing a justice framework. And I'm not the first, or even, this is not my area of expertise, but people have been really thinking a lot about environmental justice and climate justice. And as we build this new carbon dioxide removal industry, we have this opportunity to regress past harms and build things in a different way by incorporating what we hope is a justice framework. And so what would embedding justice principles into carbon dioxide removal, soil carbon sequestration look like? Well, there are kind of three elements of justice principles that are really critical and important. The first is procedural justice. Procedural justice is all about how we make decisions and making sure that as decisions are made, it's done so fairly. So people talk about inviting producers to the table. Well, like, producers should own the table, run the table, be the stewards of the table, and we are invited to consult, maybe. So it's fairness in decision making. And it's also like producers are demographically an aging white male population. That is not, that is the reality, but that was by design. It used to be that 30% of producers were Black farmers, and that's no longer the case. And there's structural sort of USDA policy that has enabled that to be the case today. We have to regress that. We have to move towards more equity and justice in both who is at the table, who owns the table, and who gets sort of the benefits of the transition. So the other thing is distributive justice, and that's equitable allocation of risks, benefits, and impacts. So right now, sort of the risks are all kind of on the farmer and the rancher, and the benefits currently are in that blue system in that graph with all the carbon market players. A lot of sort of the benefit of transition is being kind of garnered by these other entities, not the farmers themselves. And so this is about sort of distributing the benefits and the risks more equitably. And then the third thing is reparative justice, which is really important. And we sort of forget and skip that part, which is about regressing past harms. So we have to acknowledge that in the past, there have been many harms that have been done to agricultural communities, rural communities, and that includes everybody. When people think rural communities, they tend to think white, but actually like a lot of rural folks are people of color. And so acknowledging those harms head on, having a real conversation about that, and then moving forward in a way that addresses those harms in the past is really important. And so scaling soil carbon justly means community engagement, and it can't just be one-off, it's continual community engagement, working in partnership, working in collaboration. We can't forget that soil carbon projects are actually projects that happen in a community to real people who are also in community with their neighbors. These projects also have to be transparent. We have to be transparent about the risks and the benefits. And a lot of that is about boring stuff like contracting. So contracting is not the most exciting thing, but is really critical because the contract is the literal foundation upon which we do this work. And we have to have contracts that are transparent and fair. And then we have to address harms. That's both kind of past harms and any harms that are happening as a result of the project. The Northern Kenya project did not do that, and it's now going to be, all crumbling down as a result. And so I just kind of want to read this quote. When we talk about environmentally just CDR technologies, we have to make sure we're thinking about everything and everyone that goes into the project. That includes, but is not limited to, the people, policies, processes, communications, transparency, impacts, and decision-making. So that's a lot. It's not just about planting cover crops. And so I'm going to skip this and just say, we are in this moment, right? Soil is having a moment, climate is having a moment. All of a sudden, we're really caring about things that 2 or 3 years ago didn't seem so mainstream. And so I think we can make this moment count, and I don't want to let the moment pass. And we can do that by focusing on producers and regenerative agricultural systems. So not a particular regenerative practice, but a system, and the system includes the people. And creating incentives that are fostering just outcomes and solving actual problems, not problems that we think are happening, but real problems that producers are facing day to day. And those are different depending on where you are. Like if you're in Iowa versus in Montana, you're going to have some really different problems you're dealing with. And then 3, we really have to make sure we're applying scientific rigor to ensure that whatever climate benefits we are seeking are real and not imaginary, because ultimately the emissions that they're being used to offset are real. And then a friend of mine kind of said this: anything that makes regenerative practices more profitable, easier, and more socially acceptable will lead to climate positive outcomes. So ultimately, like if we do this right, there'll be climate positive outcomes. Hopefully, I mean, for sure. I'll just say for sure. And I'll just wrap with a question for you. And I asked this of folks that I was in a room with recently, and that is, would you support regenerative agriculture if it was fully embraced by a giant ag corporation? Like, would you be like, cool, as long as they're going to scale it to every acre that they touch, I would be okay with that, even if it's like a giant corporation? Or would you feel uneasy about that? And if you would feel uneasy, why? You don't have to answer. You maybe can answer over coffee or during break, but just something for you to think about, because I think it is really telling, because in the room that I was in, the answer was an unequivocal no. They would not embrace it, which is really interesting, because these are all people working in regenerative agriculture. And so you can get in touch with me at Colorado State University, check out the Soil Carbon Solutions Center. We have a cool website and an Instagram account that a graduate student runs, because, I'm old And mine is really focused on my dog and soil. And then just like put this up here, the Soil Carbon Solutions Center is really focused on building the tools that we need to accelerate credible soil-based climate solutions and measure their impact and bring them to scale. So this is the work that we do. I think there's so much opportunity for us to collaborate. I'm so excited that I got invited here because I think there's more we can be doing together as centers of interdisciplinary excellence. And so I hope this is just the beginning of that. Thank you.
That was awesome. Thank you. What kind of dog do you have?
Have border collie, half Australian Shepherd. Some days he's more border collie.
That's the way with border collies, isn't it?
Yeah,
Yeah.
you're being so border collie right now.
So we are a little bit running behind, which
Okay.
is as usual. If anyone has a burning question for Jane, we can take it now, but otherwise maybe we'll start moving into the faculty presentation portion. I think Jane's with us all day, so at lunch and the coffee breaks and everything, so we can catch up with questions then. So now for part two, moving to the faculty presentations.